Hey there, so today we're going to learn how to do a one sample t-test in R. The first thing we're going to do is we're going to open up our R Studio as we have here. And I want you to go ahead and load in library ggplot2. And if you have not already done so, you can install the package of ggplot. So you just type in install packages like this and ggplot. You can just go and put this in quotation marks like so. And that's in case you have not already done so. I have, so I'm just going to delete that, and we have ggplot loaded. So to do a one sample t-test, the first thing that we're going to need is data. And instead of calling up one of the standard R data sets, I'm just going to create some new data that we can look at. And let me just quickly walk you through the code. I'm going to create a normally distributed variable for IQ with mean of 100, standard deviation of 15. I'm going to start off by using this rnorm command just to make sure it's normally distributed. Then I'm going to round that off because IQ doesn't come in in decimals. It's integers, right? And then I'm going to create 1,000 subjects sort of sequentially. So we are kind of pretending that we have data on these people. Then I'm creating a data frame out of the whole thing. And then I'm going to show you kind of what the first several rows look like here. So if we could go into the data set, I'm not going to show you the whole 1,000 rows, but it's going to look like 1,000 subjects, and for each subject there is an IQ measure. Now, if we're conducting a one sample t-test, the first thing that we're going to want to do is to make sure that the variable, the continuous variable for which we're conducting this test, is normally distributed. The test for that is known as the Shapiro-Wilk test, and in R we just type in Shapiro.test. And then here in parentheses, if we have the data frame already defined, which we do here as IQ data, we put that first, then a little dollar sign after that, and then the variable name for which we're testing, which for us, if you remember, is IQ. So let's do that. Now, what we want to see for a Shapiro-Wilk normality test, we actually want to see a p-value over 0.05. That's what tells us that the variable is normally distributed. And here, as you can see, the variable is well over 0.05, so we do not have to worry about normal distribution. Now, one way of sort of checking that visually, which I'm going to show you, is to just create a histogram and plot our IQ data, plot IQ, and let's go ahead and make that, yep, we have that as the X variable, that's fine. I'm going to show you what this code brings up in a moment. It'll show up here on our right-hand side in our studio. Okay, so as you can see, this histogram looks very normally distributed. Hopefully you either know of already or you can find out a little bit more about the bell curve distribution for normally distributed variables. This looks very, very, very much like that, which of course is no surprise because I wanted to create data that were normally distributed. All right, so all of this just tells us that we can, go ahead with our one sample t-test, and let's say that we want to determine whether the mean of IQ is significantly different from 105, which is the mu here that I've typed in. So let's look at that syntax a little bit again. I've typed in res, just short for result, and I'm saving that, and I am doing that as a t-test here, you can see. Once again, we have the name of our data frame followed by the dollar sign, the variable for which we're testing, comma, and then mu is the test value for one sample t-test. So here basically we're just asking hey, is our sample mean significantly different from 105 here? And I've typed in res here also so that the results come up. What do we see? Well, the first thing that we see is the actual mean is 99.736. And our p-value is way, way below 0.0001. So what this is telling us is that actually our true mean is not equal to 105. Our null hypothesis is that the true mean is equal to 105, and we reject the null when the p-value is below 0.05, which in this case it is by a lot. So here we conclude, frankly, that the actual mean of 99.736 is not equal to our posited mean of 105. And you can imagine the scenarios in which this question might come up. We might have a sample mean for, say, income, and we might say, hey, is the sample of this income of people significantly different from the income mean for the entire population? That's, one possible motivation for one sample t-test. Finally, I want to show you how to do a ggplot where we can do a box plot also of the same data. And here, for example, I've put IQ on the y-axis, and you can sort of see the outliers here closer to the top and to the bottom. And you have the whole interquartile range, and you have the mean. So sometimes if you're conducting a one-sample t-test, it's nice not only to have the histogram of the variable, but also a box plot, so you can see where the outliers are and just get, an overall better idea of the distribution.